everyone. I am Swati from Sri Venkateshwara College of Engineering, second year, third sem. Now I am here to explain about the topic of optical binary research tree. Now let us start the session. The topics to be covered in this session are introduction, basics of binary trees, the need for optimization, properties of optimal binary research tree, construction optimal binary research tree, cost calculation in optimal binary research tree, pseudocode for construction, time and space complexity, applications and conclusion. Now let us start the session, that is introduction. An optimal binary research tree is a data structure used for efficient searching of elements. It is designed to minimize the average search time by arguing elements in a specific order. The optimal binary research tree is also known as an optimal binary search tree or OBST. Next is basics of binary trees. Binary trees is a hierarchical data structure where each node has at most two children. The left child of a node contains elements smaller than the node, and the right child contains elements greater than the node. The root node is the topmost node in the tree, and leaf nodes have no children. Next is the need for optimization. In a binary search tree, the average search time depends on the order of elements. An unoptimized tree may have a skewed structure, resulting in longer search times. Optimization aims to reduce the average search time by organizing elements in an optimal order. Next, optimal binary research tree properties. An optimal binary research tree has the minimum average search time for a given set of elements. The optimal order of elements is determined by their probabilities of frequencies. Elements with higher probabilities are placed closer to the root for faster access. Next is construction of optimal binary research tree. The construction of optimal binary research tree involves dynamic programming. It uses a bottom up approach to calculate the cost of each possible tree structure. The optimal tree is built by combining sub problems and considering probabilities. Next is cost calculation in optimal binary research tree. The cost of a tree is the sum of the search costs for all elements. The search cost is the product of the depth of the element and its probability. The cost calculation considers all possible routes and recursively calculates the cost for each subtree. Next is Pseudocode for constructing optimal binary research tree. Initialize a cost matrix to store the costs of different subtrees. Calculate the cost for single elements as their respective probabilities. Build the optimal tree by combining small subtrees based on the calculated costs. Next, the time and space complexity. The construction of an optimal binary research tree has a time complexity of 0, where n is the number of elements. The space complexity is 0 power n into 2 due to the cost matrix used for storing costs. However, with elements implementation and optimizations, the actual time and space complexity can be reduced. Next is applications of optimal binary research tree. Optimal binary research trees are used in various domains like language processing and compiler design. It helps in efficient searching and retrieval of data in dictionaries and symbol tables. The concepts of optimal binary research trees is also applied in decision tree algorithm for clarification problems. Next is the conclusion. Last part of this session is the conclusion. An optimal binary research tree offers improved search efficiency compared to unoptimized binary trees. It arranges elements based on their probabilities for minimize average search time. The construction process involves dynamic programming and cost calculation for optimal tree structure. Thank you for everybody watching this video.